Right, so this video is covering Algebra 1, Section 5.2. Now we're going to take what we learned about plotting points and looking at ordered pairs and the x and y coordinates and how we find those. And we're going to look at the relationships between these different ordered pairs and between the x and the y. So we're going to talk about relations and functions in this section. So the lesson opener is just sort of kind of getting your brain to look at how one thing affects the other. So using the relationship parent and offspring, so you can see we have our ordered pair notation here. Parent is your X, offspring is your Y, to state your missing element. So if the parent is a dog, then the offspring would be a puppy. If the offspring is kitten, the parent would be a cat. If the offspring is a fawn, that is the offspring of a deer. If the parent is a goat, they're baby goats, the offspring of goats are called kids. So a goat would have a kid, and a horse would have a foal. And so you can see, so looking at this, and I'm going to talk about this more later, but you'll notice that the breed, species, the type of animal that your X is determines what kind of offspring you're going to have. So X is independent. So your offspring does not determine what the parent is, obviously, because the parent comes first, right? So I want you to think of that in terms of the parent is independent. So you know if that a dog is always going to have a puppy. A cat is always going to have a kitten. So Y is dependent on what X is. So this is, we're going to talk about how X is always your independent variable and Y is always your dependent variable. All right, so in mathematics, there's lots of definitions for relations. We think of that as like maybe relatives, family, community, the connection between things. But in mathematics specifically, we use the word relation to define an association between two sets. So you can think of these maybe as in sets of numbers. Specifically, any set of ordered pairs is a relation. So relations are represented multiple ways. They can be listed as a set of ordered pairs. It can be listed as a table or as a graph. And that table can be a horizontal table, like we saw in one of our examples, the last example in our previous section, or they can be like a two-column table. All right, so let's talk about some more definitions. So the relation is the set of first elements of the ordered pairs. Okay, this is what we call the domain. Sorry, I don't have my key in front of me, so I'm having to find my words here. The domain is what we call the relation in the set of first elements, the x coordinates of the ordered pair. So the x coordinates of multiple ordered pairs make up your domain. Your range is the relation in the set of second elements, the y coordinates of the ordered pairs. So again, in terms of independent versus dependent, when I think of domain, I think of like maybe like a house would be the domain, the space, and then the range would be the size of the house. So whether it's a small one room shack, or whether it's a multi-room mansion or castle, the range determines the size. So the size of it doesn't make it a house or not a house. It just simply defines maybe the size of the house. So this is why domain is independent, range is dependent. But again, I'm getting a little ahead of myself. We'll get to that in a minute. Let's look at an example of just breaking down our domain. So the domain is the set of numbers that exist as your y coordinates in each ordered pair. So we write this in set notation. This is the set notation. Where we have this written as a set of ordered pairs. The set's name is A equals, then you've got your curly brackets, and each ordered pair is an element of the set. So this goes way back to chapter 1 when we were talking about set notations and the elements of sets. All right, so the domain is all of your x coordinates. So we have -3, we have 2. Now 2 is repeated. We don't repeat it in the domain. We have 2 of them. But we only write it once. And then we have 4. Our range is all of the y coordinates. So I have 5. I'm just going to write them the way they're given. My pen will work. I have 2, I have 4, and I have -1. Now, when you write these, always put them in numerical order. So -1, 2, 4, 5. There's your range. All right, there's another way that we use range, and I love these. My guys always like these. My visual learners always really appreciate what we call a mapping diagram. So the mapping diagram puts them, it's a variation of the Venn diagram. It's where we sort of map them out and then draw arrows to which ones are connected. And I think on y'all's example, you've got both slides right in front of you on the same page. I do not, but I'm gonna do my best here. So my domain is -3, 2, and 4. And my range was -1, 2, 4, and 5. So what we do to map this out, get a contrasting color here. Okay, go back to your ordered pairs. Your first ordered pair was -3, 5. So draw an arrow from the -3 to your 5. Then we go to the second ordered pair. Our domain was 2, and the range was 2. So it was the x coordinate was 2, and the y coordinate was 2. So we just draw a line from the 2 to the 2. In the third element, we had ordered pair 2, 4. So again, we start with 2 as our domain, and then we just draw an arrow to 4. And then the last one was 4, and we draw that to the 1. So this is a mapping diagram of the domain and the range. This gets very useful later when we start to study functions and determine whether something is a function, especially if you are a visual learner and you really like to see everything laid out like this instead of just a list of numbers separated with commas and parentheses. All right, so as I just said, a function is a relation in which each x coordinate is paired with one and only one y coordinate. Now this gets a little bit confusing because it's just saying that the x coordinate cannot be linked with more than one y coordinate. So like if we look over here, you'll notice that 2, actually the number 2 in the domain actually has 2 arrows coming from it. So it has 2 different y coordinates in the range that it's linked to, that's paired with. So that would not be a function because the x coordinate is paired with 2 y coordinates instead of just 1. All right, so I've got a bullet point of just some of the things that we know about functions and we need to understand. Functions are relations. They're just special relations. So think of this in terms of all residents of Virginia are United States citizens. So if they're a registered, I'm losing my words here, registered resident of Virginia, then they must also be a citizen of the United States. So that's kind of what we're saying in number 1. All functions are relations. However, not all relations are functions. So I will even write this. So if you live in Virginia, you live in the US. Okay. Now, if you flip that around, not all relations are functions. You say that would be like saying, if it was true, if all relations were functions, you would say, if you live in the US, then you live in Virginia. And we know that's not true. You can live in multiple other states. So some relations are not functions. And then these 2 in the middle, each function has a domain and range. So every single function the element will have an X and a Y. And then you can illustrate your functions with ordered pairs, tables, graphs, or mapping diagrams. All right, so let's go ahead and look at an example of this. So for example 3, our first one, determine whether the following relations are functions. Now, if you're really good at just knowing which numbers to look at, you can very quickly look at this and see we have a repeat of the very first one we saw in example 1. But you see very quickly that you have the x coordinate duplicated in two different ordered pairs. Therefore, this is not a function. That's what they're not a function. It is a relation. It's not a function because 2 is paired, or 2 in the domain is paired with 2 and 4 in the range. Now, if you can't see that clearly, you could always do a quick mapping diagram. Draw 2 circles and go ahead and list your, first label them, domain, so you know what you're looking at, and range. And go ahead and make a list of your all your x coordinates. So -3, 2, and 4. And then we have 5, 2, 4, and -1. So I'm just going to put those in order here. And then you can graph them. -3 links to 5. 2 links to 2. 2 links to 4. Well, instantly you're like, nope, not a function. I just drew 2 arrows from the same domain element, the 2. Therefore, this cannot be a function. But to keep it clean, let's go ahead and do the whole thing. But because of this guy right here, not a function. Let's look at our second one here. So for this one, I have 0 and 4, -1 and 2, 3 and 4, and -4 and -3. So I can look, I just kind of pick out all of my x coordinates. Each one is unique and different, 0, -1, 3, and 4. So this is a function. Each domain is only paired once to a range. But if you're not sure, go ahead and do your map. We need to map these anyway, just for practice. Label each of them. So I'm going to look 0, -1, 3, and -4, -4, -1, 0, and 3. And then I have 4, 2, 4, and -3. So -3, 2, and 4. Okay, so 2, 4, yeah. All right, so then I go back to my first pair, ordered pair. Again, each of these is its own element. So let's draw our lines. 0 to 4 is right here. -1 to 2, start -1, draw a line to 2. Got that one. 3 to 4 is here. And -4 to -3 is right here. Now, you'll notice that for the 0 and the 3, they both are linked to 4. If I wanted to do that really neat, do it this way. Maybe I can, like that. All right. So, but just the range is irrelevant when it comes to determining whether something is a function or not. It's really, you only have to look at the domain. If there is only one arrow coming from every element in that domain, you have a function. So that's all you really have to look at to determine whether this relation is a function. All right, let's talk about the notation of functions. So just like points plotted are always labeled with a capital letter, functions, we always use lowercase letters when we notate a function. And specifically, we use F and G. If you have more, you typically will have F, G, sometimes H. We tend to skip I because mathematicians aren't really known for having super neat handwriting, and I can just look like a smudge mark sometimes. So usually I'll have like F, G, H, J, and go from there. But we're not going to be working with more than one at a time. So if you're naming a function, you would have a lowercase f. So is this a function? I'm going to quickly look at all of my domains, 6, 4, and 0. Each ordered pair has a unique and different x coordinate. Therefore, yes, this is a function. So this is again set notation of a function. All right, so I've already referenced this a couple of times, but just so you have it in your notes, the variable that represents the values of the domain, that's typically your x, it's always the first number or symbol that you've got in the ordered pairs, the first one. This is called the independent variable. Because the value of the second coordinate, usually y, depends on the value chosen for the first coordinate, it's called the dependent. Like, for example, going back to our lesson opener, we would not know that the second one is a puppy unless we knew the first symbol in the ordered pair was a dog. Like a dog determines that the baby, the offspring, is going to be a puppy. A cat determines that your offspring is a kitten. So let's continue this on. Functional notation. The y coordinate is symbolized as f of x, and we read this f of x. So since y equals f of x, the ordered pair xy can also be written x f of x. So again, this also means that y is a function of y is dependent on x. So let me show you in an example what this would look like. So for example, if we have a function that we just looked at before with these three ordered pairs, if x is 6, then the function of 6 is 9. It's your y. The function of 4 is 12. The function of 0 is 4. Again, right now, we're just learning what these look like and how we interpret them. We're learning our definitions. We're learning to speak the language of coordinates and functions and relations. Later, you're going to see why it's so important to understand this and how you can use it to solve these different functions. Okay, let's go ahead and do the last one here. We have our word problem. So our example here, the local grocery store is having a sale on potato chips. One bag regularly sells for $2. This was obviously made before inflation, but moving on. Sells for $2, but if you buy two, you get a third bag free. Sorry, little typo there. So represent the relationship between the number of bags purchased from 0 to 12 and their cost using both a table and a graph. Are these ordered pairs a relation? What is the domain? What is the range? Are they a function? All right, so the first one, I have my number of bags. So and then the second one is the cost in dollars of those bags. So I'm going to start with 0. We can fill this in. So they told us to do 0 through 12. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, let's go ahead and think about this. Which one of these would be X and which would be Y? Is the number of bags I purchase in any way dependent on the cost of those bags? No. How much I'm going to pay at the register is entirely dependent on how many bags of potato chips I'm going to buy. So X is the bag of chips is our X. That's our independent variable. The cost is completely determined by how many bags of chips I buy. So it's completely dependent. That's our Y. All right, so now let's look at it. If I buy 0 bags of chips, I'm paying $0. If I buy 1 bag of chips, I'm paying $2. If I buy 2, I'm paying 4. Now, the third one is free. So that means if I get 3 bags, I'm still paying $4. Now let's keep going. Now, if I buy a fourth, I'm going to have to pay $2 more for it. So that's a 6. 5, that's $2 more, 8. 6, I get another free one, still $8. Okay, 7 I'm paying for. 8 I'm paying for. 9, that's my third, free. So I get 9 bags of chips, $12. All right, I buy 10, I gotta pay another $2. Paying again, but the 12th bag is still free. Are these ordered pairs of relations? So again, think of all of these. The number of bags is your X and the cost is your Y. Well, so all we need to do really is look at our X because, oh, well, sorry. Are these ordered pairs a relation? Well, yes, because each one is an X and a Y. Sorry, I'll put that back up there. And we have just a full set of ordered pairs. So yes, a set of ordered pairs, whoops, is always a relation. What is the domain? So we use our D equals, set notation is the curly bracket. I'm going to just start with 0, 1, and 2. So we know that these are just whole numbers from 0, 1, 2. You can use the ellipses in the middle and then do a comma and then 12. So this tells me that it's all numbers, all whole numbers between 0 and 12. The first 3 numbers, you need 3 so you can see a pattern. Once we see the pattern, we just use ellipses to fill in the blanks and don't have to write every single number. Same thing with the range. So with the range, we wouldn't write 4 twice or 8 twice, etc. So again, we're going to start with 0, but these are all 2 apart. So they're all even numbers. 0, 2, 4 shows our pattern, comma, ellipses, and then we go up to 16. Are these ordered pairs a function? Yes, because all you have to do is look at your X. Each domain in each ordered pair is unique to that ordered pair. So each domain, well, sorry, each element of the domain is used only once. And so that's how we know that we have a function. The scatter plot, the graph, we're going to do that in class yesterday. We ran out of time, so I'm just going to leave that be. You guys go ahead and I'm not working on the homework. What did I give you guys for homework? Oh, I'm going to make a video going over yesterday's homework. I want you guys to watch it and check your answers. And then I'm going to check for your homework tomorrow from section 5.1. So that's all we have to worry about now. Thank you very much. I'll see you guys in class tomorrow.